Welcome to the session on free vibration. So today we're going to discuss on the topics vibration, and that we're going to discuss on the free vibration, which comes under the module 4 under dynamics of machines. So when you're going to study about the vibration, it is very important to know whether the vibration is good or bad, why we want to study the vibration, and why we have to do this vibration analysis. So in this sketches, I showed some of the vibration analysis done. One on the motor and the engine, whatever the things you're going to consider engine, and the structural analysis, what you're going to do for a calculating vibration of an object. So why the vibration will happen? So whenever there is a fluctuation on the object, if you take this example, when you want to transfer the power, when there is external forces, fluctuations are takes place, there will be a to and fro motion of the object from the equilibrium position. That to and fro motion is called as a vibration. So when you're going to see the vibration, it has to be controlled and it has to be maintained in a proper way to give the stability to a system. So what do you mean by vibration again? So any motion that repeats itself after an interval of time is called a vibration or oscillation. The swinging of a pendulum, the motion of a flux stream, are the type of examples of a vibration. So the theory of vibration deals with the study of oscillation motion of bodies and the forces associated with. So the vibration system involves the transfer of its potential energy to a kinetic energy and from the kinetic energy to a potential energy alternately. So if the system is damped, so some of the energies will be dissipated. It means if you take your automobile, so when you are riding your automobile, what will happen? When you're going to get any bump on the road, it starts to transfer the load onto the chassis. So the chassis will give the vibration to the driver. So that will be absorbed by the shock absorbers. So that is called as a damping. So that damping, if you're using some energy, will be dissipated in each cycle of vibration and must be replaced with an external source. So if a state of vibration to be maintained. So what is the importance of vibration analysis? If you go for a structure designed to support high-speed engines or turbines are subject to vibration lengths, the design of this structure suitably leads to a catastrophic failures. So faulty design and manufacturing causes excessive and unpleasant stresses in the rotating system because of the vibration, which leads to the failure. When you go for the next, the vibration causes the rapid wear of a machine parts such as bearings and the gears. So vibration causes the loosening of the parts. When if you take any of the lathe machines or any other machines which have a maximum vibrations, so the parts, the fasteners will be loosened up. So if you take the bolt nuts, that will be loosened up and which may be lead to the accidents. So, because of excess deformation, the wheel of a locomotive can leave the track due to the excessive vibration, which results in accidents or heavy losses. So, when you're going to travel in automobile, if because of the heavy vibration, the wheel may be going out of the tracks. So, building a structural bridges fail because of the vibration. So, vibration caused on the beams may make the buildings or structures to collapse. The excess vibration is dangerous for human beings, so it may produces the noise and uncontrollable motions over there that will be a dangerous for the human beings. So thus the study of vibration is essential for a design engineers to minimize the vibration effects over mechanical components by designing them suitably. So you can say that if you're completely remove the vibration, whether it is safe for a object, so it can't completely remove vibration, so it has to be under the control and you should not over damp that one also, means overly you should not control the vibration, so there should be a normal vibration so that the motion will be taking place. So even though vibration causes undesirable effects, sometimes catastrophic failure also, it can be used for the fruitful purpose in day by day. So even in our mechanical field also. So what are the things you're going to use as advantage? So testing equipment like vibratory conveyors, hoppers, sieves, and the compactors. So if you take example, when you go for a foundry forging lab, you're using the sieve analysis where you're going to find the grain structure of the grain size of an sand. So there again you're going to use vibration for advantage for finding the size. So very fruitful in mechanical workshops such as improving the efficiency of machining, casting, forging, welding techniques. So normally you're going to use the vibration as an advantage for the equipments. So next one will be musical instruments. So you know that the music will be produced from the vibration of the objects. If it may be a guitar, it may be a tabla, whatever it may be. So it will be because of the vibration. So sometimes when you want to go for any research, if you want to research the earthquakes, so you have to create the vibration, then only you can identify what will be the rate of vibration going to take. So that can be done using again the vibrators. And again, it is useful for the propagation of the sound. So sound again, it will be propagated to the vibrations. So vibration can be eliminated or reduced by the suitable mechanism which you're going to follow now. So that is removing the external excitation if possible. So whenever the body is in a static state, if an external force is acting on that, so it automatically produces the vibration. So that if you are eradicating that, so it may be controlled using the shock absorbers, just as I said in automobiles. If you're using shock absorbers or dampers, so automatically going to observe the vibration and it may be in the controllers. Using the dynamic observers also you can control the vibration. So resting the system on a proper vibrating isolators. So isolators will be there if you're keeping that vibrating body on isolators, so that you can control the vibration of the objects. So, what are the important definition you're going to see in a vibration? So, I've shown a wave over here. So, the periodic motion. So, if you go for a periodic motion, that is nothing but the motion which will be repeated in equal interval of times. So, non-periodic means the motion will be there, but it won't be a periodic. So, irregular motions will be taking place. So, if you take the periodic motion, so you can see over there, there's a sinusoidal wave. So, having amplitude, time period, frequency, omega, and the equation. So y is going to the motion will be specified as y is equal to a sine omega t. So we can take x or y. So a is the amplitude, sine omega t, or angular velocity into time taken. Okay. So now when you go for the definitions, the periodic motion, the motion repeated in equal interval of time, that is called a periodic motion. The time period is nothing but the time taken for a one complete cycle of vibration to pass a given point. If I take a time, so if you take this as a point O and this as a point 1, so from 0 to 1, that completes one cycle. So what is the time taken from that to that point? That is called as a time period. Or if you have taken this as a reference point, from that particular point, so again the same particular point, what is the time taken? That is called as the time period. So that is always denoted by t. So that will be given by 1 by f. That is 1 by frequency. So what is amplitude? The maximum displacement. So whenever the motion takes place, so this line indicates the equilibrium position. Whenever there is a motion, the wave will be propagating. So whenever it reaches the maximum point from the equilibrium position, that is called as a amplitude. The maximum displacement or a distance moved by a point on a vibrating body or a wave measured from its equilibrium position. So that will be A. So this remains the same when it is undamped vibration. When it is a damped, so it will be automatically reduces to 0 in a given time period. The frequency. So if the frequency is nothing but how many cycles can be done. The number of occurrence of a repeating event for a unit time. How many cycle? If this is a one cycle, how many cycles can be repeated in a given time? If it may be 1 second or 1 minute, depending on that, I can define as a frequency. So natural frequency. So we know that what mean by frequency. The natural frequency is when there is no external forces acting on the body. If you're going to calculate the frequency of a particular object, so then it is called as a natural frequency. So knowing the natural frequency is very important as a design engineers, because this may give a complete analysis structure on the natural frequency. So when you go for resonance, so resonance is a major phenomena that has to be taken care by the engineers to avoid the resonance. So the resonance will take place when the working frequency of any object goes for a natural frequency equals, or it will be near to the or equal to the natural frequency. So there will be a fluctuation and the amplitude will be increasing. So that phenomena has to be controlled, so to have a proper vibrating system. So next video we're going to see about the major parts in the vibrating system.